So let's take a look at this second question there. So we want to find the limit of g of f of x, and we can do the following. According to the rule, we can actually find the limit as this way. We can take the limit to the inside of the function, which means g of limit x approaches 4 fx. So now all I need just to find what is this here. So now limit x approaches 4 and fx, which is limit x approaches 4 and 2x squared minus 3x plus 39. So that gives us 2 times, and replace the x by 4. 4 squared minus 3 times 4 plus 39. So that gives us 2, that's 16. Now 32 minus 12 plus 39. So finally the answer, this is to give you 20 plus 39, which is 59. So the limit of fx equals 59. Okay, so now what you have here, so that means that gives us g of 59. And this is g59, so now all I need just evaluate g59. Just means the function g is cube root x plus 5, so which means you can write this as cube root x, right now is 59. I got 59 plus 5, which is cube root 64. And 64 cube root is a 4. So the final answer is a 4 there. Okay, that is an easier way to do it. And or you could do the following way. You can just figure out what is gfx, the whole thing here. So gfx, which is gfx, is 2x squared minus 3x plus 39, because fx is this here. You replace this by this whole thing here. And now that equal to, oh, just a second. So then g of this means I need to replace the g's x by this whole thing here. So you're going to write cube root and replace the x by this whole thing, which is a 2x squared minus 3x plus 39 plus 5. So which gives us cube root and 2x squared minus 3x plus 44. So now I want to find the limit. From limit x goes to 4, and g of fx equals limit x approaches 4, cube root, and 2x squared minus 3x plus 44, and that equal to cube root. Take this limit to inside, limit x approaches 4, 2x squared minus 3x plus 44, and now evaluate. 2 times 4 squared minus 3 times 4 plus 44. Okay, and so same thing here. Let's give you, well, you have here 2 times 16, that's 32 minus 12, okay, and plus 44. This gives you 20 plus 44, which is 64. Cube root is 64, which is 4. Okay, same as what we did here. Either way is fine. Okay, either way is fine. That's for number 2. And number 7, in this case, again, you try to do substitution first, but unfortunately you can't. If you do substitution, that's 0 minus 0, which is 0. Numerator is 0. So that is so-called, we refer to this as 0 divided by 0 form. When you have a 0 divided by 0 form, you may have a limit. Okay, you may. I want to say you will have, and because sometimes you don't. But that's the case you may. Okay, so what causes the problem? The problem caused by denominator is 0 if you do substitution. So what do you try to do? Say, somehow if I can make the denominator, okay, and not equal to 0 if I simplify, okay, so what I have here, remember x approaching 0 does not mean, remember x is not equal to 0. Okay, so what you can do here is you go ahead to factor the denominator. X squared 6x. You have a common factor which is x. So you factor the x, you got x minus 6. Okay? So now, what happened here, this x approaches 0 but not equal to 0, so you can reduce this x, that's 1. So that becomes limit x approaches 0 and 1 x minus 6. Now you let x approach 0, the denominator is not 0 anymore. So that means that you can directly do substitution. So you have 1 over negative 6, which is negative 6 there. Okay, so that's how we do this. Solve all this kind of problem, you have to know how to factor, to reduce the common factor. That's the key. Okay? So for question number 10, I have cosine 9 theta plus tangent 9 theta divided by theta. First, I can't do substitution because that's going to make denominator equal to 0. But if I do substitution, this numerator also equal to 0. This is 0 divided by 0 form. So that means whenever you have 0 divided by 0 form, you may have a limit. Okay, so here now, what we try to do here, we try to somehow to, that theta, okay, with numerator combined, somehow I can get a limit exist. That's what we try to do. What I can do here, I'm going to simplify the numerator. Okay, simplify the numerator. I got a cosine 9 theta. The tangent equal to sine. Okay, divided by cosine. That's, you got to remember, tangent equals sine divided by cosine. Okay? So now, you can see here, this cosine, numerator, denominator, I can reduce that. So now, my numerator can only has sine 9 theta divided by theta. The thing here is, you cannot say, oh, can I factor 9? Oh, no, you cannot. Okay, remember in the class I mentioned sine theta is not equals, they're not equals sine theta. They're not. Okay, then what we're going to do here is we can only remember our special limit is limit x goes to 0 sine x divided by x equal to 1. If this, your variable, your argument, that's two things, must be same. And it goes to 0, that's limit is 1. So this case, although both go to 0, but this is not same as this. So that's not equal to 1. Okay? So how am I going to do this? Don't even think about a factor of 9. You can't. What I can do, I can multiply 9 to the denominator, so I have the same argument here. But you can't just simply multiply something to the denominator. Well, yes, I can multiply to the numerator too. So if I reduce this 9, I still go back to the original function. So now, the thing here is this thing here. Now you have the same argument. You can, this argument goes to 0. Now you can apply the special limit, which is 1. So now you can see I can write 9 limit theta goes to 0 sine 9 theta divided by 9 theta. Okay, must be same argument. Then you can apply the special limit equals 1. So now you get 9 times 1, which is 9. Okay, so then your limit is 9 here. That's what you have number 10. Okay. For this case, sine to the 4th x divided by x. Again, so here we do not know sine 4th x divided by x limit equal to. Can we do substitution? Unfortunately, you can't. When you do substitution, that's 0. That's 0. Okay, so which means 0 divided by 0. This is not defined there. But you know, although it's like 0 divided by 0 form, you know they are not exactly equal to 0. They are close to 0. That's when we say approaches 0. So approach 0 not equal to 0, the ratio may still exist. Okay? So what we try to do here is, and we're going to do this here, we're going to still use the special limit. Okay, special limit x approaches 0, sine x divided by x equal to 1. Okay, so what we can do here, because this you have 4 sine x times together. So I separate 1 out and combine with the denominator, which is x. And but the numerator, you have 4, I separate 1, I still have 3 of them left. Okay? So now, what do we do? What do we do here? You can see, look at that thing here. This is exactly that thing here, which is limit is 1. But that thing, limit exists? Yes, because when you do substitution, sine 0 is 0. Limit does exist. So therefore, I can take a limit for each of them, which means I can take a limit to sine x divided by x, because I already know this limit exists from the special limit. That's why I also know its limit exists, because the sine 0 is 0. That's why you can directly do substitution. That might use special limit. Special limit, this is 1. Then do substitution, let's give you sine cube 0, which is 0. So now the answer is 0. So you are done here. Okay? So that's something you got to remember. That's not, like this case, not trig identity involved. Okay, that's why you got a trig identity involved there. Okay, the most important thing here for this case, don't consider factor out the 9 there. You cannot factor out 9. Okay, in order to do this, you have to make this argument, and that's same. That's really I multiply 9 to the denominator, so they have the same argument. When you multiply denominator to 9, you have to multiply the numerator. So then that's whole thing going to be equivalent to what you had earlier. Okay? So that's for the 4 questions.